Now, plant a tree and save the planet. It's one of those mantras that we've become used to hearing, really, in the battle to reduce carbon emissions and slow down global warming. But more trees doesn't just mean less carbon in the atmosphere. A new study shows that it also leads to significantly more rainfall. Researchers estimated that a 20% increase in forests across Europe would lead to 7.6% rise in rain in the summer months. That's quite a jump. Well, I'm joined now by Frances Seymour, Distinguished Senior Fellow at the World Resources Institute and a leading figure in the field of deforestation and reforestation. All things forestation, really, Frances. First things first, I mean, when I think about the Amazon rainforest, I suppose we shouldn't be too surprised at these findings. Are you surprised at all about the scaling of rainfall there in this forecast?
You know, I was interested to see these findings, but not surprised that the impact of land cover change could have impacts on the climate other than just through the carbon cycle. I mean, we're all familiar, as you say, with the need to stop deforestation and recover a lot of our lost forests in order to keep carbon out of the atmosphere. But we're increasingly appreciating that greenhouse gas emissions are not the only way that forests interact with the atmosphere. And in fact, these other non-greenhouse gas pathways across scales, whether impacts of forests on precipitation or on wind speed or on local temperature, are also quite important and in fact can be more significant at the local scale in terms of the physically lived climate experience in particular places than the impacts of global climate change.
Yeah, I mean, on the face of it, it looks like a sort of added bonus in a way that there's more water to come down. But of course, we have flooding just as we have drought. I suppose that's part of the challenge, is knowing where you might want to put more forestry.
I think that's right. And one of the exciting things about the new research that's coming out based on our increasing ability to do geospatial monitoring with the, improved and modeling with improved data and computing power, that we're actually getting better at being able to net out these different effects and see, spatially their distribution. But I would hasten to say that, one of the things that came out in the article was, in fact, building on this unique role of protecting forests and forest restoration as a climate action, because it is simultaneously a mitigation action as well as an adaptation action, in that, forests do store carbon and so have that mitigating effect on climate change, but simultaneously often can moderate the severity of local extreme weather events in a way that's important for adaptation.
Can I ask you, Frances, I mean, it has become one of those things, hasn't it? Everyone knows that you could plant a tree and you could perhaps even take away a little bit of your own carbon footprint in doing it. It feels like a very good thing. There's a programme in Wales for planting sequoia trees, which obviously we are more familiar with seeing those in North America, for example. There must be some risk, isn't there, of trying to plant different trees in different places expecting to get the same result.
Of course. I mean, we always have to plant the right tree in the right place at the right time. And there have been some unfortunate negative experiences of afforesting areas that were not previously forested, especially with non-native species, that can have unintended negative consequences of various kinds, either on local biodiversity or on local hydrology. So, first best is protect the natural ecosystems that we still have. Second is to restore them with native species and restore native ecosystem function, and be careful about afforesting areas that haven't been forested before, because that's where things tend to go wrong sometimes.
Beware of the unintended consequences. Frances, thank you very much indeed. Frances Seymour.